Question number 19. It says an object rotates with constant angular velocity. Constant angular velocity means angular acceleration should be equal to 0. Can there be a net torque acting on the object? If angular acceleration is 0 according to Newton's second law for rotational motion, which is net torque is equal to I times alpha. If alpha 0, so net torque should be equal to 0. There will be no net torque. Can there be a net torque acting on the object? No. There cannot be a net torque acting on the object. Net torque acting on the object must be equal to 0. Question number 20. If an object is at rest, can you be certain that no external torques are acting on the object? If an object is at rest, complete equilibrium, which means linear acceleration is 0, and also angular acceleration is 0. At rest. Angular acceleration 0 means net torque must be equal to 0, but net torque acting on the object is equal to 0, and no external torque acting on the object is 0 doesn't mean the same thing. Net torque can be 0, but there could be two torques. For example, one of them can be clockwise, so it can produce negative torque. The other one can be counterclockwise, it can produce positive torque. So their magnitudes can be equal when you add them. That's why external torques possible, but their sum should be equal to 0. Question number 21. Two uniform solid discs of equal radii roll down an incline without slipping. The first disc has twice the mass of the second disc. How much torque was exerted on the first disc compared with the amount exerted on the second disc? Now, torque depends on force. We know that. Yeah. If I want torque to be greater, force acting on the object should be equal to greater. This is the equation. When you roll two discs on a surface, on a uniform, on an inclined plane, so there are two forces acting on this disc. One force is gravitational force Fg. Second one is normal force Fm, perpendicular to contact surface, remember. Here is the axis of rotation. About this point, every point on this disc is moving around this point. Then, Fm is expansion of Fn is passing through the axis of rotation, so it cannot produce a torque. But Fg, no, it is at some distance to the axis of rotation. It has a distance. This is a lever arm. So then, Fg produces a torque. Fg depends on what? Depends on mass. Okay, it says that the first is twice the mass of the second one. If mass twice, what will happen to the force? Gravitational force also twice. If force is twice, torque is twice. Yeah. Reason for this to roll down is the gravitational force, torque produced by gravitational force. So this torque depends on gravitational force. Gravitational force depends on mass. If mass doubles, gravitational force doubles, torque by the gravitational force also doubles. Question number 22. A 30 kilogram uniform solid cylinder has a radius of 0.18 meters. 30 kilogram uniform solid cylinder has a radius of 0.18 meters. And the cylinder accelerates at 2.3 times 10 to the power negative 2 radians per second squared as it rotates. And this is alpha. How large is the torque? This is a very easy one. Torque is equal to I times alpha. Alpha is given. Only we are going to write cylinders moment of inertia equation in here, and we will find it, which is 1 over 2 mr squared. M is given, R is given. M multiplied by alpha, you'll get the answer, so that's why calculation you can do it on the phone. Question number 23. A 350 kilogram merry-go-round in the shape of a horizontal disc with a radius of 1.5 meters set in motion by wrapping the rope around the rim of the disc and pulling the rope. So how large a torque would have been exerted to bring the merry-go-round from rest to an angular speed of 3.14 radian per second. Yeah, it's a disk. Merry-go-round is a disk. It's in the horizontal. And around this disk, rope is wrapped around this, and then this rope is going to be pulled with some force. Of course, this force will produce a torque. This torque will start this merry-go-round to accelerate. And in the question, acceleration is given. Or it will be calculated by the given. From rest. Initial angular speed of the merry-go-round is 0. It increases to angular speed of 3.14 omega final. It happens in 2 second delta t. So calculate the torque. How large the torque? So I can use the Newton's second law for rotational motion. Torque is equal to I times alpha. So torque I is that it's a disk, and you know disk is 1 over 2 mr squared, 1 over 2 m r squared. First we should calculate alpha. We can, because alpha is equal to omega final minus omega initial divided by delta t. So omega final is 3.14, initial is 0, divided by 2, result 1.57.
Yes.
Radian per second square. So insert in here alpha, we will calculate the torque. M is given, so it is 1 over 2, M is 350, R is 1.5, alpha we calculated as 1.57, so multiply them all, we will calculate torque. How much was the torque calculated with this calculation? 618 Newton meter, correct? 0.6. Okay, this is the torque. Now maybe they can go this question further. How? What if calculate the force? The force applied tangentially. So I am going to use torque equation. This time I will use definition of torque. What was it? F times distance, which is equal to radius, is equal to torque. Yeah, this torque we are going to write in here. R is going to be written in here. We can find how much force is applied tangentially to this maybe around 2. Yeah, extra. It can be asked. Okay. Question number 24. Is angular momentum always conserved? No. Every conservation law has a condition. So angular momentum is conserved if net torque acting on an object should be equal to 0. Otherwise, it's not conserved. Question number 25. Is it possible for two objects with the same mass and same rotational speed and angular speed to have different angular momentum? Let's check. Angular momentum equation. Moment of inertia times rotational and angular speed. This is the equation. Moment inertia equation includes a constant, depends on shape, yani C, coefficient, and mass and R squared. Mass and radius and rotation speed. And there are 4 factors, in fact, and angular speed depends on. Angular can be affected. Coefficient, mass of the object, radius of the object, and angular speed. It says that 2 of them is the same. What are they? Mass and angular speed same. These are same. But we want result to be different. It says that the result is going to be different. If all are same, for example, coefficient is the same, mass is the same, radius is the same, rotation speed is the same. So in this case, result for both of them would be the same. But if these 2 are same for both, when you multiply them, result would be same. But if the coefficients are different, this is different, or and radius is different. If one of them is different for these shapes, it can be coefficient, and shape could be different. But it says 2 objects, it doesn't specify the shape. It can be disc, it can be cylinder, it can be sphere, it can be hollow sphere. If it is different shape, when you even radius are the same, result is going to be different. Or shape can be the same, both can be sphere, but radius can be different. In this case, result is going to be different. It can be possible, different. So 2 objects with the same mass, same rotational speed can have different angular momentum A if shapes are different. One. B, radius are different, or both are different. It's also possible in this case. Question number 26. A child on a merry-go-round moves from near the axis to the outer edge. On a merry-go-round, what happens to rotational speed, yani angular speed of the merry-go-round? It's an easy one. So this merry-go-round is a disc-shaped object. So this child is moving from axis, from this position to that position. So as it is moving, child's moment inertia is increasing. If moment inertia of the system increases, according to conservation of angular momentum, angular speed should decrease. Yeah, rotation speed decreases. Question 27. Is it possible for an ice skater to change her rotational speed without any external torque? This is what we learned right now. Why not? Ice skater, external torque can be zero because it's on ice. On the ice, friction is zero, that's why net torque zero, so angular momentum is conserved. But if the ice skater reshape its body by opening arms, closing arms, so moment inertia increases. So according to conservation of the angular momentum, this is unchanged. If I decreases, omega should increase, or vice versa. If I increases, omega will decrease. Yes, we can, ice skater can make his angular speed greater or smaller without any external torque. Question. Now this question is also ice skater question. Ice skater use conservation of angular momentum to produce high-speed speeds. This is normal. This question is answer to the previous one. How can an ice skater change its rotational speed? When they bring their arms close to the extremity or far, yeah, by changing moment of inertia. Imagine that an ice skater moves her arms inward, yeah, doing like this, cutting the moment inertia in half. Yani I decreases by 2, divided by 2. Therefore, doubling angular speed. According to conservation of angular momentum, it should be. If we consider the rotational kinetic energy, we see that energy is doubled in this situation. Now, this is a question, 2023, I think. Yeah, these are given in fact. If moment inertia is halved, angular speed doubles, rotational kinetic energy also doubles. And they are giving the answer to you. In fact, why is it so? We should discuss that first. How this happens. Now, I will first discuss it. Okay. So, three quantities we have. I, omega, and kinetic energy, rotation. If moment inertia is I, angular speed is omega, rotational kinetic energy is 1/2 I omega squared. When you cut moment inertia half, and I changes to I/2. According to the conservation of angular momentum, angular speed should double. Then rotational kinetic energy, let's calculate it. 1/2. What happened to the I? I changed to I/2. What happened to omega? It doubled. I should square 2 omega. Then result. It's going to be, if we are given 1/2, I/2 times 4 omega squared. 4/2? Take this 2 right here in front of the equation, so I will get it. It is twice of 1/2 I omega squared. What was 1/2 I omega squared? It was initial rotational kinetic energy. So final is twice. This is important. Important thing is this. If, for ice skater, for this type of question, if moment inertia is halved, angular speed doubles, rotational kinetic energy also doubles. What if moment inertia is decreased by 3? If I decrease by 3, omega should increase by 3, rotational kinetic increase by 3. Now which is now 3. If I decrease by 4, omega increase by 4, rotation kinetic also increase by 4. If I doubles, omega halved, rotational kinetic energy is also halved. That's all. This never changes this way. But this question, another part. Does angular momentum is conserved? Yes. But kinetic energy is not conserved because it doubled. If kinetic energy is doubled, they are asking you, where does this extra kinetic energy come from? Because initially it was only 1 over time omega squared. Then it becomes choice of that. Where does this extra energy come from? They ask. It's coming from when the ice skater is pulling his arms closer. There is muscles have force. This force is doing a work. When you pull an object by a force, you do work. And I told you that when talking about the elastic potential energy, this work is added to the system as energy. Yani muscles are doing work. This work done by your muscles edits your body as rotational kinetic energy. That's why your body starts to rotate faster and faster. Okay, and question number 20. A solid ball starts at a height of 3 meters and rolls 20 degrees slope. A solid disc and a ring start at the same time and same height. Both ring and disc have the same mass and radius as the ball. Which of these 3 objects will win the race to the bottom if all roll without slipping? Yeah, there's an inclined plane. On this inclined plane, we are going to release 3 objects. One of them is solid ball, yani sphere, solid sphere. We draw like this. The other one is disc, only disc. The other one is ring, yeah? Yes. Ring. So they're from the same height, rolls 20 degrees slope. So which one will arrive, will win the race? Yeah, which one will come to the bottom earlier? It depends on the speed. Which one is faster? It will arrive bottom earlier. So that depends on final speed at the bottom. The one which will win race arrives at the bottom with the greatest speed. Then which one is it? I will use the equation. If an object rolls or an incline from rest, so we can find the final speed by equation 2gh divided by c plus 1. So in this problem, h is 9.81, same for all 3. H is same height, same for all 3, but c different. Depending on the shape, c different. If you want v final to be greater, c must be smaller. Which one is the smallest? C, of course, so it is 2 over 5, 0.4 c. As disc, 1 over 2, 0.5, and ring is 1. So that's why smallest c, fastest. So it will arrive at the bottom, the first. And question number 30. 35-kilogram bowling ball with a radius of 30 centimeters start from rest at the top of incline, 3.5 meters in height. Find the translational speed of the ball. It's the same question. Again, an inclined plane. It starts from rest again. It's a bowling ball, so it is a solid sphere. You can choose 2 over 5 meters squared. Find the translational speed at the bottom, and we final. I'm going to use again same equation. We final is equal to root of 2gh divided by c plus 1. C is bowling ball, solid ball, 2 over 5. And g is given, h is given, everything is given, so you can find the translation speed. And question number 21. A solid ball with a radius of 1.2 rolls 6 meters down a ramp that is inclined to 7 degrees with horizontal. Again, if ball start from rest, what is the angular speed of the ball at the bottom of the incline? Okay, this is the inclined plane. And this is a solid ball again. It start from rest, omega initial 0, the initial 0. And this time, 6 meters down the ramp is not height, we know it, it's the length of the incline. So from here until there, this length, which is going to be displacement of the ball, it's going to be what, 6 meters and after 6 meter, what is omega final? But to get omega final, I have to first calculate V final. V final. You know, we can calculate V final. This angle is 37. If this angle is 37, I need to calculate H. H is hypotenuse times sine of the inclination angle. Hypotenuse is 6. Sine of 37. Sine 37 is 0.6. Yeah, 0.6, I think 3.6. H is 3.6 meter. So C, solid ball again, 2 over 5. Yeah, 0.4. After that, first calculate V final by using equation 2GH divided by C plus 1. Insert all the given into the equation, which is 2 times 9.81 times H is 3.6 divided by C, 0.4 plus 1. So result is going to be when we final 7.1 meter per second. But question is omega final. We know for roller object, V and omega related by this equation. So V final is calculated, R is known, omega can be found by this equation. How much did we calculate omega?
35.1.
Yeah. Question number 33. A bucket filled with water has a mass of 75 kilograms and is attached to a rope that is wound around the cylinder. This is the case. So this is a cylinder, around the cylinder there is a rope, at the end of the rope there is a bucket. Cylinder with a radius of 0.075. Yani this radius is 0.075. This is the front view. From rear side, if you look like this, you are going to see this is R of the cylinder. And around the cylinder, there's a rope. At the end of the rope, there's a bucket. Then you are looking like this. Rear side means that. Front side and rear side. Because rear side is better to see the distances. A crank. Crank is this. This is called crank. You are going to hold the crank and you are going to rotate the crank. A crank with a turning radius. Yes, radius of the crank is given. Because it follows a circle, radius of that circle, followed by the crank, is 0.25. If you look from the rear side, you are going to see that this is where you are holding. From center to the place you hold, that distance is the radius. It's given as how much? 0.25. Yani, crank radius is 0.25 meter, and cylinder radius is 0.075 meter. What minimum force directed perpendicular to crank? Yes, the force must be acting on the crank perpendicularly, so it produces the most torque, like this. Required to rise the bucket at constant speed. Constant speed means A0, alpha for the cylinder is 0. Yani net torque 0. Yani torque produced by the bucket and torque produced by your force on the crank must be opposite in direction, same in magnitude, and some of them 0. Yani, I'm going to calculate torque produced by the bucket first. Now I'm going to write a equation for torque produced by the crank, then I will add them, make them equal to 0. So, say that one of them is positive, one of them is positive, the other one should be negative. Which one you say positive or negative, depends. It doesn't matter. So I say this one is positive. Yeah, this one is positive, the bucket produces a positive torque, let me say. So, Fg must be calculated. It is mass times free fall acceleration. Mass is 75, which is 9.81 multiplied 36 Newton is the Fg. This Fg is acting in here, surface of the cylinder, and then perpendicular distance of R. R is the perpendicular distance. So we can find torque of G. So it's going to be Fg times R. Fg is 736 times R is 0.4, this 0.075 result? 55.2 Newton meter. This is torque produced by the crank. Pardon, by the bucket, not crank. Then I'm going to calculate torque produced by the crank. But crank will produce an opposite directed torque. Now if this is positive, that should be negative. Okay, vice versa. Ama This is not the case. Cases they are opposite. Yeah, one of them positive, the other one should be negative. So I choose this one to be positive, that one is going to be what? Negative. So negative F times, F is the force, linear arm is 0.25. This is the crank radius. 0.25. So when I add them, result should be equal to 0. So 55.2 minus 0.25 F must be equal to 0. Yeah, which means these two terms must be equal in magnitude. And after that, divide by 0.25, you'll get the answer 0.25. How much is the result? 221 Newton. Yeah, and the force applied by your hand on the crank should be equal to 225 Newton. All right, and this is another popular question. Two spheres look identical, have the same mass. One of them is hollow, the other one is solid sphere, but by looking at them, you cannot differentiate them. Their colors are the same, shape is the same, output. Which method would determine which one is which? Okay, now, they look identical, have same mass. If masses are same, FGs are same, because FG is M times G. Weights are same. So it says, weight them on a scale. If you weight them, same. So you cannot differentiate. Drop them from the same height. In the library, you learn that if two objects are released from the same height, they fall at the same time because air resistance is almost neglected. So they will fall at the same time. This cannot make a difference. But roll them on an incline makes a difference. When you roll them on an incline, the one which is a smaller seal, which is the solid sphere, will arrive at the bottom earlier. Hollow sphere will be late because of the seal. So then the answer is roll them on an incline. Question number 34. If the torque required to loosen a nut that holds the wheel on a car has a magnitude of 58 Newton meter, what force must be exerted at the end of the 0.35 meter long range to loosen the nut when the angle is 56 degrees? Okay, this is about required torque. Required torque required. How we calculate? Force required times distance times sine theta. So we are going to calculate this. So transfer this sine to the other side and you will find it. So then F required is going to be, so torque required, how much is 58? Divided by D sine theta. D is length of the range, 0.25 times sine of 56. The rest of them is your calculation. Answer is how much? 200 Newton force is required. Question number 25. A 23 centimeter screwdriver is used to pry open a can of paint. If the axis of rotation is 2 centimeters from the end of the screwdriver blade, and a force of 40.3 Newton is exerted at the end of the screwdriver's handle, what force is applied to the blade? First, this is the screwdriver, and this one, in the drawing. It has blade is tip, handle is in here. To open the can, you should push the screwdriver blade under the can, and around the edge of the can, you have to rotate it. Yani axis of rotation is the position where the screwdriver touches the end corner of the can. So here is the axis of rotation. And question said that the blade axis of rotation is 2 centimeters from end of the screwdriver blade. Blade is in here. From blade until this axis of rotation, yani end of edge of the can, it is 2 centimeters. This length is 2. Total length is given is 23. This is 23 centimeters. In this case, from x rotation until the force is applied, that point is going to be 23 minus 2, yani 21 centimeter. It says that what force is applied to the lid, if force applied by the handle is 84.2, because your hand is in here, you are going to push it like this. So 84.3 Newton force is applied on the handle. Then, of course, in here, force between the blade and the lid is the question. So, question is the force acting on the lid, because blade is pushing the lid with upward force F, but every action has a reaction. So, if the force acting on the blade is on the cover and the lid is F, so reaction also must be F, but in opposite direction. This is the force acting on the blade by the lid. Same magnitude. The magnitudes are same. And if I find this, I also find that. I'm going to apply rotational equilibrium for the screwdriver ball. Because if rotational equilibrium is provided, net torque is 0, object is ready to rotate. Slightly greater torque makes it to rotating so that you can open this lid. So then I'm going to start the case when net torque is equal to 0. Then this blade is ready to rotate, so lid is ready to open. So torque produced by the force acting on the blade of the screwdriver is force times distance and perpendicular distance. Force is F, which is unknown. Distance is 2 centimeters. So you can write it as meter, 0.02 meter, because it is counterclockwise in the drawing, so I'm going to write it positive. It's not, if one of them is positive, the other one should be negative, or vice versa. So then first torque produced by this one, I'm going to calculate. Torque is negative. 84.3 times, this time distance is 21. Sometimes students are taking this 23. No, 23 is the total length. It is the distance from force until the edge of the can, which is the axis of rotation. So 21, 0.21. So then you are going to add them. You are going to make them equal to 0. I think this one is
negative
17.7 Newton meter. So this time you are going to add them and make them equal to 0. You have 0.02 F, negative 17.7, result must be equal to 0. Transfer it on the side. 0.02 F is equal to 17.7. Divide by 0.02, divide by 0.02. Result is, how much we calculate result?
885.
885 Newton. Yeah, the force acting on the lid is 885. The force acting on the blade by the lid is also 885. Where action reaction pairs are equal in magnitude, opposite direction, and acting on different objects.
Okay. If this is asked, will the figure be given or do we?
No. I just draw the speaker.
You draw.
Yes.
We
You just learn it. My question is going to be this way, just so that you should be worried about it. They are the same question with different numbers. And question number 36. 0.1 kilogram meter stick is supported at its 40 centimeter mark by a string attached to zero. An 0.3 kilogram mass hangs vertically from 5 centimeter mark. A mass is attached somewhere on the meter stick to keep it horizontal. If the force applied by the stick attaching the meter stick is all 19.6 meters, determine the value of the unknown mass and the point where the mass attached to the stick. First, we are going to draw 1 meter long stick. Meter stick means 1 meter long stick.
It's right at the source though.
Did you find it? Wow. Meter stick means 1 meter long stick and 100 centimeter. All right. So this is the problem. In your book, is generally the questions are really, literature is interesting, and they're making a real book, like college level. This book is normally,
This is like a ruler.
before the college, it is not high school level. Normally, high schools a little lower than that. And this book is used not at high school.
Yeah, anywhere smart.
Yes, but the questions aren't that hard. they ask me questions. This one is not asked, that's why. 1 meter, yani sen de seni böyle et, and then learn the book. Yani daha ne olsun, learn the book. Okay, I will draw for 1 meter long stick first. So it's a 1 meter long stick, meter stick. It's from, on this meter stick, from 0 until 100, there are markings. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And support, it is a 0.1 kilogram. So it's a uniform object, so central mass is midpoint. So I will draw this 0.1 kilogram from midpoint. But in fact, we can convert mass to force. In fact, scientifically we should. However, result, because they ask unknown mass, and multiply 9.81, divide again at the end, it's one way. So I am going to consider that mass, not the force. I'm not going to write. That's why I will draw mass from midpoint, and from 50 centimeter, this is 50 centimeter marking, I am going to draw 0.1 kilogram, just like force, because it takes a force. Then, it says that it is supported from 40 centimeter mark. From 50, 10 centimeter earlier, somebody reading 40. From 40 centimeter, it is supported by a rope. And attached to the ceiling, ceiling we attach it. Another mass, 0.7 kilogram mass, hangs vertically from 5 centimeters. Another marking here. 5 centimeter, you are going to support another mass which is 0.7 kilogram. A third mass. Now this one cannot make the equilibrium because this is axial rotation. 0.1 closer to that. Also 0.7 farther, produce more torque than this, so it will turn. So then a third mass is needed to provide equilibrium. It says that a mass, a third mass, is attached somewhere, but I predicted it must be this side. Somewhere on the meter stick to keep it horizontally and balanced. I don't know where it is, but randomly I put somewhere. I'm not sure about this. I will calculate it in part B. But I know it's a mass mx. I will say unknown mass mx. To keep it horizontal. If the force applied by the string, yes, of course, force string applies that force, which is a tension. This tension force applied by the string is given 19.6. Ft is 19.6 meters. Determine the value of the unknown mass. And mx is the question. Now, there are flow forces. There are 1, 2, 3, 4 forces. One of them is unknown. If one force is unknown, which equilibrium conditions is enough? Translation. I can apply translation equilibrium. Only these are masses, this is force. Generally we do mass to force, but mathematically convert force to mass. Because result we will calculate the mass. Mathematically okay. Of course scientifically what we do is a bit say that this is a headway, okay? Instead of doing so many calculations, we are going to do that. I am going to calculate corresponding mass to this force by using the mg. So Ft is equal to m times g. M is equal to 19.6 divided by g. 19.81. I think it's going to be 2. Was it 2?
9.
It was 2, I think. Almost 2 kilograms, yes. Then I represented this force a mass in upward direction. Such mass is not possible, but upward direction. Now all are masses, so I can find mx by applying translation equilibrium. Translation because it says that sum of the forces or sum of the masses. Sum of the masses acting along y-axis must be equal to 0. So 0.7 is positive y, positive 0.7. But Ft, negative y, pardon, sorry. 0.7 is negative y, negative 0.7. This one is positive y, am I right? Positive 2. This one is negative y, negative 0.1. And mx is unknown. But I know mx is negative. Why? So I write negative, I will mx in number. Right, so result is going to be equal to 0. Like force, we did this.
I thought we were doing it by the class.
No, that's for
But it's for rotation equilibrium is not needed in here. Rotation equilibrium long.
Yes.
So if one unknown, apply translation equilibrium. We will do it in part B. With the distance, because distance,
Then we use the
yes, we have to. There's another way. So you are going to add them 0.7, negative 0.7, negative 0.1, negative 0.8, plus 2, 1.2. So it's going to be 1.2 minus mx is equal to 0. Then mx is going to be 1.2 kilogram. We found it. This force, this mass must be 1.2 kilogram. This is part A. Now part B. Part B says here that find the point where the mass attached to the steering. How many centimeter, from how many centimeter you are going to suspend this mass. Say that this is x centimeter, I don't know number, I will find in mathematics every unknown. We say x. Then, of course, if I am going to find a distance, I have to apply rotational equilibrium. There's another way. To apply rotational equilibrium, I have to know the forces. Yes, they are known. Masses are known instead of forces. And distances must be determined. But first, I have to choose exerted. Choose location of one of the unknown forces. But all forces are unknown. All forces are known. So then choose one of them. It doesn't matter. It's up to you. Which one is easy for you? Choose that. Force is exerted. I will choose here. This point as axis. So then let's make this out of the equation. 19.6 yeah. It's force. The rest of them is mass. We also convert it to mass, but choose that point x orientation. Alright, so then distance. Now let's determine distance one by one. How much is this length? From 0.7 to x orientation.
It's 45.
35.
25. 45, we read them, but this is upside down. So 40 minus 5, 35 centimeter. That's 35. 5 plus 35, 40. This is the every tricky here. And what about distance from 0.1 and to x rotation? What is this then?
10.
Yes, from 50 to 40, 10 centimeter. I don't know straight. What about the distance from this position until x rotation? How can I write it?
We're gonna
X.
10 minus x.
No, I said them. X in this position.
X minus x.
X minus?
10.
No, 10 minus
What is
x.
this position?
X. Acceleration.
What is, no, how many centimeters?
X minus x.
X minus?
X minus
40.
Yes, X minus 40. For example, if it was 90, if it was 90, how do you get it? 90 minus 40. If it is X, X minus 40. Mathematical X minus 40. So I will write this one as X minus 40. Directly I will get the answer. When I calculate X, it's going to be answer. So I have to, of course, calculate the torque of each force, each mass one by one. Again, I'm going to write the torque. This one produces the counterclockwise rotation, positive torque. But this one produces negative, this one produces negative torques. So I have to calculate them one by one. Okay, let's calculate. Let me choose another color. Okay. I like this color. Okay, let's find this. Positive torque. 0.7 kilogram. Still, I use the mass because at the end, as I said, they will simplify. Then it's up to convert one again force. So 0.7 times. What is distance from x rotation to the force? 0.35. You can write 0.35 as a meter. Even use centimeters. Okay, this question. But yes, all again on right and left always use centimeters. But for not to get this as a habit, go over it. Okay. So multiply that. 0.7 times 0.35. How much? How much is this? You calculate
It's
this.
24.5.
24. No, it is in kilogram centimeter. Now use this one. I wrote in my solution in the book in the magazine as centimeter. Now let's get it kilo.
It's 0.24.
0.24.
224.
24 It is kilogram times meter this time, not Newton times meter, kilogram times meter. Okay, now torque of Ft is 0 because it's on axis of rotation. Then torque of 0.1, it is negative. How much? Multiple 0.1 times, it's 0.1 times 0.1. 0.01 kilogram times meter. Go on. Calculate this one's torque. Negative. It is 1.2 is the mass. Distance is x minus 40. So I calculated all of them. Then I'm going to add them and make them equal to 0. Let's calculate that. So 0.24 minus 0.01 minus, distribute this over it, negative 1.2x, negative 1.2 times 40 plus 0.48, result is 0. So then, do this addition, this is the operation, 0.24 minus 0.01 plus 0.48.
It's error.
Huh? Error? 0.24 minus 0.01 plus 0.48.
0.71.
71 is equal minus 1.2x is equal to 0. Transfer the negative other side. 1.2x is equal to 0.71. Divide both sides by 1.2. Divide 1.2. X is going to be 0.59 meter. 0.59 meter, 59 centimeters. Yeah, this position is going to be 59 centimeters. Yeah, this end of mass must be supported from 59 centimeters. In this case, this meter stick will stay horizontal, yeah, in